Hey guys, a few days ago the GHI team got me really excited with the following post. Can the BrainPad code itself? Where Gus basically talks about building a environment that runs on the BrainPad and can execute code, even go as far as debugging, etc. So really interesting stuff. And since I don't get to code much these days, and I definitely haven't touched C# in years, I thought it'd be a good opportunity for me to jump in and do something fun again now over the holiday season. So this weekend I created this repository. For now it's a private repository, but hopefully if there's any interest I'll get to make it public and others can maybe help me work on this. So let me show you what I've got so far. What you see now is just a very simple REPL that I created to test the language. Obviously it's all a console application. I don't actually have a BrainPad to run this on yet, but if all goes well I should get one soon. So let's jump into the language quickly. What can it do? Well, you can do normal things. Assign a value to a variable, print that value to the screen. You can also create functions. Function is introduced to the keyword func. Name your function, define the arguments it will take, and open the function body with a curly brace. Let's just do something simple here. Return x plus y. Close our function. Now our function is declared. We can call that function. Nothing too surprising there. Now one of the other cool features is, as far as data types, currently it handles numbers in the form of doubles. It handles strings as well, but it also treats functions as data types. So for example, I can say variable a is equal to add, right, which is my function I wrote earlier. And from this point on, I can actually call that function through the variable a. So a open brackets 3, 4, right? And you'll see that it actually added 3 and 4 because it called the a function. If we look at it internally, you can print a, and you'll see it tells me that internally that's a function declaration. That variable is, for all intents and purposes, an alias to the add function. So that allows us to do some pretty cool things. I can write another function, call it do work. It's going to take an argument f and 2 other arguments. We'll call them a and b this time. The argument names, of course, are arbitrary. Right? And I'm going to say that this function will print line f, which is the argument, the first argument to the do work function, which I'm going to say is a function callback that takes 2 variables, and we're going to pass a and b into that function call. Right? And now I can do things like this: do work, open brackets add, comma, and the 2 arguments on the pass to it, and I get 7. So do work now invoke the function for me. I could write another function, let's call it subtract. And return x minus y. And now if I call do work and I say I want you to invoke the sub function with those arguments, and we get -3. So why did I add this? Number one, it was fairly simple with the structure of the interpreters. I put it together. And the other reason I wanted to have this capability in the language is if you want to add the ability to support callbacks for interrupt handling, etc., it becomes fairly easy now to have a function that you can specify the interrupt you want to handle and the function that needs to be called when the interrupt is triggered. Another fairly neat feature that I put in straight away into the interpreter is the ability to handle custom built-in functions. So just to show you here very quickly, you can add a new function. Like here we have the print function and the print line function that you see me use. They're actually not specified in the interpreter themselves. They're just built-in functions or native functions. Right? And it's as simple as adding an instance to this array of the type built-in, specify the name that you want to use to reference that function, and then you pass it a static function that it will be called whenever the interpreter sees this function name, right? So let's take a quick look at what print looks like. So we've got the print function, which will call back to the native print function in this case. You see it's over here, it's a static member, returns an object, so you can return values from these functions, and it receives an arg array, which is just the arguments that were passed at the call point. The pass context is if you want to report errors, the context will give you things like the line number and the column that you're currently on in the source code so that you can report errors. This one's fairly simple. We won't have to report any errors yet. So we'll just iterate through each argument, call console write for that, and we don't have any return value, so we just return null in this case. Print line, same kind of thing. We'll just reuse our already existing print function and add a write line at the end. Nothing too fancy. Let's take a look at len, right? Len will take the string argument and return the length of that argument. So implementing that, again, implemented as a native function. Fairly simple. You can validate your arguments. I said I have to have at least one, actually must be one argument. And in this case, if it's not, we'll raise an error. So this first part is really just a string. We pass the context in. If you pass the context in, this raise error function will automatically show you the line and column that was in the context. And then if you've got any other arguments that that string needs to have replaced, you can just pass them in here. So in this case, it was telling me that I expected one argument, but I got arg length arguments. Right? And then you can also go and check the data type. In this case, we want to make sure that our argument that came in is a string. We can't do the length of a double. So we're doing a simple as string. If it comes back as null, it wasn't a string data type. So we'll raise a type mismatch error in that case. And similarly, we implemented abs. So you can see adding new functions like cosine, etc. would be really simple to do. Right, let's see a few more things that the language can do. We've got for loops. So again, I can either do it in a function or I can do it interactively. So let's say for I equals 1, semicolon I, semicolon, semicolon I equals I plus 1. Right, simple C-like syntax for the for loop. I've done away with the parenthesis just because they don't add much, and parsing them just meant more lines of code as I was typing and building up the interpreter. So it was a choice, fairly simple to change that choice. That's what I've gone with for now. Print line I, and when I close that, because it was a direct statement, as soon as I closed off that function body or that the body of the for loop, it executed and ran. We've got for statements, we've got if statements with full expression evaluation and or parenthesized. Everything that you'd expect to have in the language is there. The error reporting, and that's a little rough and ready at the moment, simply because I only had 2 days to work on it. As an example, add, as you might recall, expected 2 arguments. I want to pass just a single argument, and yeah, it tells me that line is line 1. So the error at line 1, column 4, argument count mismatch. It'll tell me, I can show you some strings as well. There's hello, message 2 equals world. And I can say print line message plus 2, and there you see the string work as well. Okay guys, that's all for now. Thanks for watching. You all have a great day and have a great holiday season.